So hi again, I'm Dave Lucia. Sophie already introduced me, but I've been doing Elixir in production since 2016. It's my first time at ElixirConf. I've met a lot of great people here, so I've been having a lot of fun. And this is my son, Owen. He started crawling actually this morning, so I'm excited to see him tomorrow. Thank you. All right, so Surface. Surface is a component library that's built on top of Phoenix LiveView. We've been using Phoenix LiveView at SimpleBet for 2 years, and starting in August, we have started using Surface in production as well. This talk, I'm going to be... sorry, I'm a little nervous. I'm going to be talking about Surface, which is a component library, and I want to talk about it from my perspective and how I came to Elixir. So everyone has their own journey coming to Elixir. Many of you maybe came from Ruby. For me, it was working with Node.js and in the JavaScript community. And now that I've spent over 5 years in that community, sorry, excuse me. All right, sorry. Now that I've spent over 5 years in the community, my love for the people, the technology, have really solidified. And to appreciate where we are, I want to take a moment to reflect on where I came from and where others might have come from in building JavaScript web applications. All right, so some might remember the early web. So back in around the year 2000, many early websites were simple server-rendered HTML. HTML tables were the go-to solution for layout. That's how you pretty much threw everything on the web page. And around 2004, 2005, a couple things started happening. So the browser wars were in full swing. We had Firefox emerging onto the scene. ECMAScript 4, which is the standardization for JavaScript, was coming in. And this new thing called Ajax was invented. And actually, briefly, so Ajax was this enabling technology where you can make requests back to the server, get data, and use that to display dynamic content on your web page. Now, in order to build dynamic content on your web page, such as a clock that trailed your cursor, or moving to the next form element, or validating as you're typing in a phone number that it was correct, you rendered your HTML on the server, and then you sprinkled in some JavaScript, and this would modify the HTML. And the focus was primarily on taking the existing HTML and tailoring it to your needs, swapping elements in and out, adding classes. And we still do a lot of this today. So this was just a quick example of showing the current time on the page and live updating. This is a very common style for building web applications at the time. Now, after this new era of JavaScript applications was enabled through Ajax, and we had more powerful JavaScript, tools like jQuery, Move Tools, Dojo came onto the scene, and made it so that you could develop applications faster. There were more ergonomics that were built on top of JavaScript that simplified browser APIs and allow you to focus on modifying the DOM, making API calls to your server, etc. Through this progression, certain patterns started to emerge that were taken from server-side technologies. Don't know what's happening. All right, coming back here, and I think this dongle is haunted, so that's smooky. OK, all right, we got a race here now. So MVC framework started coming onto the front-end scene with JavaScript. These were patterns that were taken from server-side rendering, but were being applied in JavaScript and allowing users to build more interactive websites, all in JavaScript, all on the client. And this started enabling different patterns, more expression for front-end developers. And these also started introducing the idea, or popularizing, maybe not for the first time, the idea of using templates to render data on the client side. Now, these MVC frameworks typically had a render function. We're all used to this now with rendering data in Phoenix. But what was interesting about some of these template languages like Mustache or Handlebars was that they could build DSLs, and these DSLs could be tailored to rendering HTML, rendering strings, and deviate from the actual language itself. So whenever you wanted to render data on the client through a template, you would have your template, pass the data to it, you get HTML, you'd stick it in the DOM. But if you wanted to re-render a template, you'd either need to use something like jQuery to then modify that HTML that was generated, or you need to re-render and replace the whole thing. So around the year 2014, this huge boon of JavaScript frameworks came on. And these powerful JavaScript frameworks allowed developers to build highly complex web applications all within JavaScript instead of server rendering and then doing some templating on the client side. And these frameworks fundamentally changed how websites were developed and allowed JavaScript developers to pretty much build the entire application all within one language. And with this was born the concept of a single-page application. Now, the enabling technology for these single-page applications was the virtual DOM. And instead of having a template and re-rendering it and replacing the entire contents, what it would do is it would build this tree, it would diff the trees, and then selectively apply what had changed between subsequent renders. And this allowed for writing more declarative code like JSX and React, and was even more ergonomic. Now, once developers started realizing that they could build these single-page applications, they started running into issues with the ability to have SEO-enabled websites, and so they started rendering data on the server side and then rehydrating it on the client. And I would be remiss without mentioning Node.js, which was basically the innovation that kicked off all of the tooling that made React possible, because you can now have a compile time step in JavaScript and convert from JSX, which is this HTML-aware syntax, right into JavaScript, tooling, bundlers like Webpack, and all these tools that made it a lot easier to be a JavaScript developer. And so what we were left with was really two different styles of applications that were starting to be built. Maybe there's more styles, but popular ones were the server-rendered HTML plus JavaScript, sprinkling some stuff in for dynamic content. And then you had the client-side heavy single-page application where everything was rendered in JavaScript. And all the server was responsible for was APIs, GraphQL, et cetera. So when Phoenix Live View was introduced back in 2018, in my opinion, it fundamentally changed the way that web applications could be built. That entire layer of writing JavaScript on the client, having to write APIs, it removed that entire middle part of the stack, and instead you could just make function calls and not have to worry about deploying a GraphQL API or writing an interface for your code. And what I see LiveView as is LiveView is this enabling technology that in Elixir, it allows us to build rich, dynamic applications all within Elixir. So about a year after LiveView was built, Marlis had an idea for creating Surface. And Surface is built on top of LiveView. And what it is a component API that adds many different features like a template DSL, all for building rich user interfaces. And Surface's main goal is to add ergonomics on top of LiveView. So while LiveView is this enabling technology that allows this whole new paradigm of building web applications, Surface plans to make it easier to do so that you could build faster, more reliably, and with more joy. And it does this by borrowing the best from the JavaScript community. So Surface's key innovation is learning from frameworks like React, Vue, Elm, Svelte, and taking the patterns that have converged in the JavaScript community that are the great ideas that all of these frameworks have really adopted, and bringing them to LiveView via this Surface template syntax. So I want to show you what Surface offers us as Elixir developers who are working in live view. So the first thing that Surface does is it adds this HTML-aware template and component syntax. And you'll notice that this is not exactly Elixir. But if you've ever done any React or any Vue.js, it should look very familiar to you. And all of the syntax here is tailored towards writing HTML and generating markup. So because it is not exactly Elixir, it can innovate in ways that Elixir can't. We can add features. For example, I'm rendering a list of games, and if there are no games in the list, I could say no games today. And so we're adding an else to a for loop, which wouldn't really make sense outside of the context of generating HTML. But in the context of generating a template, this is a really powerful pattern. Another really common pattern is, I have some logic and I want to conditionally apply a class. Well, with the Surface template syntax, you can pass, actually it's almost like a modified keyword value list. And if you have a value and it's truthy, it will render the class. And if it's falsy, it will not show the class. Now, this idea in React is that components have APIs, and you can add prop validation so that you know the shape of data that your components accept. And Surface adds this feature where you can annotate all of the different properties that are being passed into your components. You can mark them as required. You can give them default values. You could say, my values must be in this enumeration. And it can take these at compile time and actually throw errors that prevent you from compiling your code until you correct and adhere to the contract of your API. What's even more powerful about this is because this is all annotated at compile time, you could use this to build a lot of tooling that we'll see in a moment. So here's a quick example of I have a button, but when I created the closing tag, I missed the slash. And this won't compile. We'll get an error. And we could do the same thing if I forget to pass a property, compile time error with a helpful message. If I'm forgetting to pass in a slot, which we learned about this morning in live view, compile time error. If I'm not passing, if there's only green, red, and purple, and I pass yellow, we can get a compile time error for that. So Surface adds this concept called slots, and slots come from the web component API and then was popularized by Vue.js. And what slots are is they allow you to build these reusable containers where you can predefine behavior, and then when you're using the slot, you could pass in arbitrary components, HTML, whatever you want, and encapsulate this behavior so that you can use them in different contexts. Let's move on here. And slots are this reusable component building block. So here I have a match card, which is an example taken from something we built at SimpleBet. And I can have a sport-agnostic way of displaying matches. And then I have a slot that's defined there. And I could show the score for football versus baseball by passing in a different scoreboard into the slot. Now, I talked about the property API that Surface adds to components. And what I mentioned is so powerful about this is that because we have this information at compile time, we could use this to build really powerful tools. And so my favorite feature of Surface is the component catalog. And this is documentation that is generated from your components. When you're writing a property and you have a doc string on the property, it gets built into here. It shows all the values that it accepts, the types that it expects. And what's so interesting about it is that you can pre-can examples. So here I have a list of buttons, and I've got different color buttons, different size buttons, which I realized I broke with the HTML, or excuse me, the Tailwind grid that I added. But you can bake out all of these examples and rapidly iterate on developing them and see them all change at the same time rather than having to go back into your app and get to that one right page and see, okay, does it fit right here? Instead, you build up these suite of examples. And this is not a new idea, again. This is taken from Storybook.js, which is a common way of building style guides and component catalogs in JavaScript. Now, it's cool to see pre-canned examples, but you also want to be able to play with your components and property test them, right? So here we have a very simple example of a form, and this is taken from the Surface documentation. And I could take this example, and I can type in my email, type in my name, see the data that's being passed into the property, and see it rendered, which is that form right above, all within the context of this component catalog. And this is super easy to get out, and it allows the rest of your team to take these components, your design team to help develop and help QA the components that you're building. Macro components are super interesting. And actually, what we were all seeing right there with those examples with the code and the rendered components above it was an example of a macro component where it was taking the code at compile time. It was grabbing that string, throwing it through a makeup, some syntax highlighter, and then also rendering the component as it were. So here, this is an example of a markdown component where I'm writing literal markdown inside the contents of my component, and then at compile time, it runs that through a markdown compiler, and boom, I've got HTML. Surface has community component libraries, and some new ones are being added. During SpawnFest, someone built components for UIKit. We're hoping to add components for Daisy UI, which is kind of like the free version of Tailwind UI. So some off-the-shelf components where you can start designing and composing interesting dynamic websites, all without writing any JavaScript or really being a designer. Now, Surface focuses on ergonomics, and something that's always driven me crazy when writing templates is that they become a mess, and they're hard to format. Everyone has their own way of doing it, and despite differing opinions on the Elixir formatter, I think it's a really good thing for the community, and it just really it takes away conversations that waste time. And Surface has a formatter. Actually, Paul, who's in the audience, wrote it. You run mixed Surface format. It formats all of your template. Your template could be in a template file. It could be embedded inside your Elixir, and it will still format it. And this is a super powerful and ergonomic feature that you could put into your CI, et cetera. So Surface is new, and it's evolving. And from version 0.4 to version 0.5, we had breaking changes for the syntax. Surface added a Surface convert function, mix task, and to go and move from the breaking changes to the new syntax, you just ran this once and you're done. We did this at SimpleBet, and it was the easiest thing I've ever done. And this is really about the ethos of Surface, which is making it easier to work with and to provide tooling for cases that would be otherwise tedious. So these are all available in Surface today, and that's really exciting because these are really powerful features. And Surface is pushing LiveView forward. So this morning we heard Chris McCord talk about all these amazing features with HTML-aware template syntax, heeks, slots, declarative properties coming, function components. And these are actually all ideas that started out in Surface that Marlis, the creator of Surface, contributed back to LiveView. So LiveView is this space where we can sort of experiment in this way and take these ideas from the JavaScript community and bring them back to LiveView. And another thing that I think is really important is that we're looking at that template syntax. Surface provides optionality in the same way in the JavaScript community. You've got Vue.js, you've got Svelte, you've got React. People have different preferences, different use cases, and it's really great to not be in a monoculture and to have those options when you want them. So quickly to compare, on the left we have a Surface template file, and on the right we have a Heeks template file. And you could see some of the differences. You've got like partial Elixir code that's inside of these brackets. And you could say that the Surface template, it's similar, but it's a little bit more concise. It's easier to read. And when I talk about ergonomic features that Surface adds, I think maybe the most important one is that it's just a Surface template. You don't have to know how to pronounce eeks or leeks or heeks. Just Surface. All right, so a lot has been brought from Surface back to LiveView. What's coming up in Surface? Well, we're getting parity with the recent release of Phoenix 1.6 and Phoenix LiveView. So function components, slots are all coming. Actually, they already exist in Surface, but we can basically delete a lot of code that's in the Surface library and depend on LiveView directly. We've got dynamic components. So if you're rendering a list of heterogeneous components that have the same API, you could just pass a module, and it's a little bit more ergonomic way of rendering these lists of components. You've got recursive components for if you're building like a tree in HTML, it could refer to itself. And we have Surface and init. So let's see. If we're doing OK on time, I can share what some of these look like. So Surface init is a tool that I think it deserves its own talk. And this is for the developer experience of bootstrapping Surface into your project. So what you do is I have a Phoenix project that has LiveView in it, and I want to get Surface into it as well so that I can start building components using the Surface API. I run mix Surface init, and it adds it to my project in the same way that mix Phoenix new would. But it does it in a little bit of a different way than Phoenix does, and in a way that I hope to see coming to more projects in the Elixir community. So this is building on top of this amazing library called Sorcerer, which can parse Elixir code. And what it does is it applies patches to your Elixir code. So we'll look for a file. It will parse the code in that file. It will then apply a patch. And if it sees that it can't make that patch, it will suggest a manual way of adding it. So this allows you to do pretty interesting things. You could run the init multiple times, and it will apply it, or it will detect that it's already applied it, and it will move on. I mentioned dynamic components, but again, you're rendering a list of, maybe in my case, at Simplebet, baseball, football, basketball games. I have components that are all the same API. I could just pass the component, as you see up top, and it allows me to cut down on all this if-else. So some upcoming things that we might be adding to Surface in the future. More options to Surface init. So maybe you want to start building components using Tailwind. We can add the -- Tailwind, and boom, you've got Tailwind all configured for you, so you don't have to go through the manual process of ES-build and adding all those features. Same thing for the other component libraries that we hope to add, like Daisy UI. That patch API that I was showing in the mix Surface init, we hope to make that public so that if you're building your own suite of components and want to add an init function, you could pass an argument, hook into Surface init, and boom, you made it really easy to get new people using your components. Some other things like computed properties, handling state changes within components. We're excited about adding some DSL syntax where it makes that a lot easier, which I still find to be a pain point today. And then improving on compile time, validations, taking the best from Elm and having that empathetic compiler that kind of coaches you along as you develop. And if I want you to leave with anything today, it's that Surface is important. Phoenix LiveView is maybe niche in the greater technology community, and Surface is maybe even more niche. But I think it's really powerful. It's actually very mature, and you could build really interesting things with Surface. And the best outcome for Surface really is that Surface and LiveView continue to converge and maybe even have enough in common where you could use Surface components in LiveView and vice versa. And another important thing, and why I shared the history of JavaScript at the beginning, is that Elixir is a growing ecosystem, and we need to be welcoming to other communities. And what I see Surface is as a bridge to the JavaScript community who's familiar with building React and Vue applications. And this is a great way of bringing people into the community, showing them something familiar, but then sharing that you can use the stability, reliability, and scale of the Beam VM to build novel products that maybe are really difficult to build in another technology. So I want to say thank you to the LiveView and Surface teams who are incredible and have built some really interesting technology that I love to use every day. And at my work at SimpleBet, we're able to make use of and build amazing products with a small number of people. So special thanks to Marlis, the creator of Surface, who helped me with these slides, and also Paul, who's in the audience. And one more thanks to SimpleBet, my employer, who allowed me to be here and where we get to use Surface every day. And thank you.